Welcome to the Ecovapor Tank Commander VMS launch webinar. We're really excited to have you here today to introduce this new innovation from Ecovapor. Here to tell us more about this new solution is a panel from the company, including Jason Rowe, Chief Executive Officer. We have Hans Mueller, Chief Operating Officer, and Jeff Wilson, Strategic Marketing Manager. They will be our guides today. Jason, I'm going to hand it over to you.
All right, thanks, James. Appreciate the intro and appreciate everybody being with us today. Thank you for your time this morning. We're excited to be here with you guys today, and of course, we're excited to be sharing a new product, a new innovation from Ecovapor that we will get to. So, in terms of a quick agenda for you today, I'm going to start with a bit of an introduction just on who Ecovapor is for those of you that aren't familiar with us. We'll talk a little bit about causes and sources of emissions, and then of course we're going to transition into the VMS system itself and some of the field results that we've seen to date. So we look forward to the discussion, and of course look forward to any questions you may have at the end. So for those that aren't very familiar with Ecovapor, this is kind of the easiest way we describe our business, or kind of the our Ecovapor in one slide, if we like to call it. But we always kind of start with the problem that we are looking to address when we're talking about our business, and that of course is that we're looking to eliminate the waste of this valuable energy resource that we work hard to produce. And so we know that the production process is responsible for the lion's share of upstream oil and gases emissions, which you can see here, 80% of the contribution and 60% of those being waste emissions. And that, of course, is where we focus, and our business has always been focused on the elimination of the wasted natural gas out there in the field today. So we really focus in two areas: oil and gas solutions, which is probably what those of you that are familiar with us are most familiar with in our business, but then also on the renewable natural gas side as well, biogas. When you get into landfill, dairy farms, swine farms, etc. And so what we do is we enable 100% gas capture, and really, the punchline of both of these verticals is that, one, we can profitably maximize the sales of these natural gas streams, and ensure that all of this gas is pipeline ready and able to be moved down the pipeline, and making sure that we're not wasting this valuable resource that we work hard to produce. So a quick snapshot of Ecovapor and kind of where we are today. As you can see by the map, we have a pretty good spread of geography at this point. We are corporate headquartered in Denver, right there by our kind of early in operations where we started there in the DJ. We also have operating centers north of Denver in Greeley, and of course in the Permian Basin. But you can see we're now operating in all the oily basins. And you can see a lot of the purple dots starting to appear on the map as well, which is RNG applications that are either coming to fruition or will be here in the near term. So by the numbers, just real quick, as you can see, we have around 200 installations in 7 oil and gas producing basins. We're now in the midst of our first commissionings of our RNG projects. And one thing we're really proud of is that the customer count continues to grow. So we currently have around 35 active customers, ranging from the small of the small to the large of the large. And we of course at Ecovapor continue to drive innovation. We're not sitting still. We continue to learn from our customers, and we continue to learn every day from our operations. And we're ultimately here to solve their problems. So just real quick, for those that haven't heard about some of the products that are a little bit more established and widely deployed in the field today. So our environmental solutions start with the 02, kind of our flagship product that we're best known for. And this is a system that helps to eliminate oxygen from natural gas streams. This helps us to enable full gas capture from a tank battery, including not requiring a BRT, flow through to the tanks and, enable that gas to be captured and of course purified before it hits the gas sales pipeline. But then, and then also you can see our sulfur sentinel there on the right, which is solid base media H2S removal system. And then, of course, on the bottom here is what we're here to discuss today, which is our VMS E300. And we're excited about it. And I won't go too much into it because I know Hans is going to hit on it a lot in the tail end of the presentation. But, this is about 100% gas capture, really managing the elimination of the flare and the venting from your tank battery. It bolt-on installation, very easy to integrate into your operations. And of course, can also help to eliminate a second VRU in an existing site. So we're excited to talk about that, but once again, we'll get into that in greater depth later on in the presentation. So before we jump into the details on the VMS, and some of you may have picked up on some of this if you were at our last webinar, but we wanted to touch on some of the sources and causes of these wasted gas streams and emissions that we see out there today. So starting with the EPA estimates, and especially how we are, the way we're using the emissions factors that are coming out of Subpart W. And, we hit on earlier the production process, of course, being the large contributor. But, I think it's important that we also look within there where these emissions are actually coming from on a given production site. And so as you can see from the data, identified on the left, pneumatic devices, a big contributor according to this data. And then you see flaring in tanks. And then on the right, based on these estimates, where's the flaring coming from? So of course, associated gas, a major contributor, and storage tanks. And so, with our focus on storage tanks, we always like to highlight that, well, based on these estimates, this is a meaty problem. Number 3 source is tanks and tank flares. From the total emissions footprint. But then on the flaring side, of course, the second largest contributor. But I think what's interesting to work through now is we've seen a lot of unique, interesting, and valuable technologies coming up through the monitoring side, whether it be aerial, drone, ground-based, continuous, or your typical LDAR team with their OGI cameras. I think what's interesting now is that is we're starting to kind of move from modeled emissions to measured emissions. And it's always interesting to explore what some of those differences may be, which is why we're going to kind of walk through a few case studies here with you real quick. So starting with this first one, and once again, if you caught our last webinar, we were privileged to be joined by our friends at Bridger Photonics. And so here's some data coming out, a couple of studies that they were involved with. One being in British Columbia, the second being in Permian. And as you can see, covering 167 sites on one and over 5,000 pieces of equipment on the right. And so what's interesting is you start to look at this and you start to see some material movement from the figures on the previous slide. And so in both of these instances, clearly identifying the tanks as the largest contributor to these emissions, and the way we like to look at it as well, wasted product on a production site. And so you can see some other, some other tidbits here popping up, like separators looking like another major contributor. But still, you look at flares, tanks, and separators, and that's the lion's share of the emissions. And this is, of course, quite a departure from what we've seen in the data coming out of the EPA emissions factors. And then moving on to another case study that many of you have probably read or are familiar with. A Permian operator employed a handful of different monitoring techniques to look at their own assets so that they could actually take a step back and figure out how to make the most meaningful impact on their emissions footprint on their production sites. And so they used a fixed wing aircraft with Bridger. They used drones, which was Avitas, a Baker Hughes company. Then they also used truck mounted and ground continuous, including Scientific Aviation. And so, what was interesting is they actually, presented the difference between the two of what they had modeled their emissions to be and what their actual to be. And here you can really see it starting to stand out. Okay, tanks and tank flares is 68% of the emissions that were reported on their well sites. And then, if you remember earlier, we were talking about 37% modeled emissions, which come from the pneumatics and the fugitives. Well, you can see that's now down to 8%. So from 37% to 8%. And I believe they went from 12% of their anticipated emissions on the tanks up to 68% of their emissions being from their tanks. So once again, a stark contrast from what they've observed in reality versus what they were predicting, what they were modeling. And then one last study, and then we'll kind of get into the summary here, which is And this was a study done by the EDF, and you can see this at the PermianMap.org. All these statistics on PermianMap.org, and they used once again a variety of monitoring techniques: aerial, ground, OGI, and once again, though, and I'm sure you guys are all kind of catching the theme here at this point, but they see 76% of the emissions coming from the tanks, and then flare stack being 15%, and then everything else kind of lumped into other. So once again, what we kind of see here as we move into the summary here is that as we start to learn as an industry, and we start to kind of really get our hands around where the source of these problems are, I think we're going to be able to start to drive really meaningful mitigation techniques as well. And so if you kind of look at this summary slide here, with the light blue being kind of what was coming from emissions factors versus the dark blue, which is what was actually coming out of the data from actual measured operations, and you can it speaks for itself here. But of course, what this highlights is that, look, we really need to focus on how we can mitigate these tank emissions. We really need to focus on how we can mitigate the flares and compressors here, and make sure that we're properly managing, capturing, and putting to beneficial use these gas streams that we have. And so key takeaways here is we've kind of talked about tanks, a major source. And then, and in fact, when we start with the factors, was already identified as one of the top three, but then through direct measurement, of course, is the largest source of emissions. And then, I think the kind of main punchline we see here, though, is that when we compare factors versus what is actually happening out there, we're going to learn, and we're going to continue to learn. And I think that, the data is pretty clear and speaks for itself. But what we're excited about is that, technologies are coming about that can actually help to mitigate this. And we know that no one wants to emit this product. I mean, it's a product that we want to put down the sales pipeline and ultimately profit from, and make sure that the hard work our industry does is put to beneficial use. And that's exactly what Ecovapor is about, and that's what we're here to do. And so, but to us, it's interesting as we kind of look through this data and really start to apply the learning so that we can actively manage and mitigate some of the problems that we see in the field. And so with that, I'm going to go ahead and hand over to my colleague, Jeff here, who's going to talk a little bit about what causes some of this venting and flaring before we get into then the new product release, which Hans will talk us through.
Thanks, Jason. Yeah, obviously, if we don't understand some of the causes of the problem, then we can't deal with the solution or address the issue. So let's talk about venting and flaring, which are really the source of emissions from tank batteries. When we talk about venting, if you're not familiar, atmospheric storage tanks operate basically within one atmosphere of pressure. They're not pressure vessels. There's an overpressure relief that typically relieves at 8 to 12 ounces of pressure, and a vacuum relief that typically opens at 2 to 3 ounces of vacuum. And this is just to protect the structural integrity of the tank. So we're talking about less than 1 PSI of pressure is allowed in this tank. Well, the other thing is the tanks typically do not have controls of the pressure. They're just receiving fluids, voiding vapor. Truckers or pipes are taking the liquids out. And these tanks then are subject to really upstream and downstream factors. The upstream factors that affect the pressure in the tanks are things like variable production of oil and water, production methods such as plunger lift, where there's slugs, if you will, of oil produced at one time, dump valves at separators, the trim on the valves, whether they're snap or throttle trim, creates a variability in production. API gravity of the crude, the size of the VRT, there's a whole host of issues. These tanks are sitting at the edge of the property and trying to, if you will, respond to all of these variable issues that are occurring upstream. Then there are some downstream issues where you're trying to take the excess vapor or pressure out of that tank quickly, but you've got a flare that's 75 or 80 feet from the tank, and it has to go down a line. There's a pressure drop in the flare system. and how fast that can respond to a change in conditions is often an issue. I saw many years ago quite often that tanks, when there would be a surge of a production, the flares would try to kick up their performance, their volume. Typically, they couldn't do quick enough, and the Inardos on the tanks would start venting. So the tanks really have in most cases, do not have any active control, and they are really somewhat incapable of responding to all these variable issues with a relatively small amount of pressure as a margin to work with. And when that margin is exceeded, you either release raw hydrocarbon into the atmosphere, or in terms of vacuum, you're pulling atmospheric air into the tank and contaminating the vapor in the tank. So it's really the lack of any real control of the tank, which is the issue. Secondly, let's go to flares. So Jason gave some data, and I don't know if you picked up on that, but flaring, according to the EPA data, is about 1/4 of the upstream industry's flaring comes from tank gas. Flaring of tank gas for years was the normal practice, so the gas was relatively low value. There really weren't regulations dealing with it. So it was quite common. And then particularly with the advent of Quad O, the idea was to begin to try to capture a portion of that gas to reduce the emissions from the tank battery. And the common configuration that we see a lot is a vapor recovery tower with a small compressor skid. The vapor recovery tower was put in front of the tanks because it operates at a higher pressure and has less likelihood of oxygen contamination. And so that vapor recovery tower collects some of the gas from, I don't know how many, Hans, 40 or 50 field installs. We've seen typically 40% more gas when we start working with the tank vapor. Put another way, the VRT is about 60–65% efficient in terms of capturing the vapor. We could go into the reasons for that. That's been covered in previous webinars. Be glad to talk to you, but there's a variety of reasons. But basically, 1/3 to 40% of the vapor at the site is not captured by the VRT, and it goes to the tanks. And without any real concerns or ability to control quality, and with the the frequency of contamination of oxygen in very, very low pressure environments, the typical practice is to flare it. And that really has to do with quality. I mean, if there was an assurance that that gas could meet pipeline specs, particularly in oxygen, where pipeline specs are something like 10 parts per million, then you could sell all that gas. And that is what we do with our 0-2 models frequently, where the operator is able to turn a flared product into revenue. One other comment on flares, you'll read more and more about high destruction flares. That really has to do with the ability to destroy or burn the volatile hydrocarbons, the organic compounds. High destruction rate flares do not address NOx, which is a particular issue in non-attainment areas. Also has does not address GHGs or CO2 at all. And in fact, some high destruction rate flares use assist gas to get very high stack temperatures to ensure a high destruction rate. And now we're in a situation where we're burning gas to burn gas. So the solution is to deal with the gas quality, and then you can sell all of that gas, 100% of it. And that's what we do typically. And it's not, next slide, please. It's not a small issue. We don't have data on all the tanks in the United States, but when we look at the equipment that we have, each one of our E300 model, which is the most popular model, can treat roughly 250 million cubic feet a year of natural gas. And the fleet we currently have installed, you remember that map at the beginning of the webinar, the installed base of our equipment has the capacity to provide enough heating to heat roughly 1 million homes, close to 1 million homes, or roughly 2/3 of the Denver metropolitan area. And it's avoided CO2e by capturing that gas instead of selling it, is roughly the equivalent of removing 800,000 vehicles from the highway annually. So this tank gas is a significant financial and energy resource that needs to be preserved. And then also, quite obvious, if you capture it, put it in a pipeline, there are no emissions. So to us, it's the obvious choice, particularly in this environment. And some of this has changed. I mean, I know that flaring used to be quite normal, but we have a lot of changes going on. We have the ESG movement going on. We have an increasing focus on regulations. I was listening to information the other day on the issues regarding non-attainment, particularly in the Permian. And so things are changing, and there's going to be increasing focus on some of this. And I think we have a solution for you. Thank you. Hans, can you tell us about the VMS?
Thanks, Jeff. Well said. Hi, everyone. I am co-founder and COO of Ecovapor. My name is Hans. Thanks again for your time and attention here today. Let's jump into looking at the solution that Jeff just teed up that addresses all causes of tank emissions, both uncontrolled as well as controlled. So we just discussed the ways that tanks contribute to upstream production facilities' emissions profile, including venting and flaring, and how that tanks are the largest portion of emissions footprint of upstream production facilities, and that 80% of upstream emissions originate from the production process. 60% of that 80% is waste. So tank batteries really do pose a real challenge, and perhaps a larger challenge, and if you ask me, an opportunity than was recently understood. I think we can all agree that venting is probably not good for the environment. It directly contributes to ground level ozone. It's also an artifact of tank batteries being passive in their operation. As was just discussed, they're caught in the middle between separators and either flares or combustors, neither of which actively responds to tank pressure conditions. So the solution to venting probably should be active and dynamic management of tank pressure. And on the other side, flaring, combustors or flares have historically been relied on to control the balance of vapor that's not captured upstream of the tank battery. And those volumes can be significant in material. And it's also true that the contamination in that stream prevents its sale. It's not a new idea to hook a compressor up to a tank battery and push that rich, valuable vapor into the sales line, but it's also not a new thing that pipelines don't accept that, especially if it's contaminated with anything that's out of that gathering specification, including oxygen. So the solution there either is to prevent the introduction of contamination into that stream, which can be hard or worse, or to actively control it. So what can we do? What can be done? Well, today, a single system can address all of these challenges and provide full capture for that tank battery, allowing operators to achieve net zero around those tanks, while minimizing installation requirements. So let's look a little bit closer into that, what that solution looks like. Allow me to introduce the vapor management system. We call it the Tank Commander. It is a fully standalone product that completely manages, that is, harvests, purifies, and delivers for sale 100% of tank vapor on a location. The VMS product is unique in that it actively addresses two issues common to those tank batteries on upstream facilities in a single package. The first is that, again, that passive nature of tank batteries, and it does this by actively managing that tank pressure, controlling it tightly to a desired set point by providing active control on both sides of that pressure window. So on the high side, we're eliminating venting. As well, on the low side, we're avoiding vacuum conditions or air inbreathing during oil loadout or when water is transferred, things like that. And the second part is where the VMS actively manages that gas quality and the issues that can be associated with that that would otherwise prevent midstream gas gathering lines from accepting that vapor if it is contaminated. The VMS is a genuine bolt-on. It can capture roughly 40% of a facility's flash gas that the typical combo of vapor recovery tower, VRU, and flare configurations leave behind. And that said, I think it's also fair to say that of course the VMS is also beneficial to newly completed facilities. So now with the Tank Commander, the vapor management system, one system can address the air emissions normally associated with tank batteries by converting them into a true revenue stream. It provides full capture of your vapor stream. There's no more finger crossing, hoping that the contamination won't make its way into where it's not, and does that while minimizing that LOE by eliminating the need for additional compression with no compromise in performance. So the VMS, let's just look at the specs on it and where it came from. The VMS builds on Ecovapor's 12 years of experience in both harvesting and purifying tank vapor. Again, from the standpoints of both LOE and minimal maintenance requirements, we think that the VMS can be viewed as a Goldilocks solution. It does what is needed to address these challenges, all of them, both pressure and contamination, while minimizing what I would call the pain in the butt factor. It's really easy to install and operate. And the blower on this package is specialized for this application. It allows 50% higher discharge pressure than most other competitive blowers would. But at the same time, going back to that Goldilocks side, it's not a compressor. There's no valves, there's no packing, there's no active lubrication system. It's simple in its nature, which means it's inherently reliable and inherently easy to maintain. Also, fair to say that a single controller ensures the compatibility of the rotating equipment that collects that vapor, as well as the gas processing equipment that purifies it. Instead of fighting each other or lagging to respond to one another, as we can see with multiple third-party systems on a well site, that's not the case. If anything, these two subsystems enhance each other's operation. And one of those subsystems being the 02, we slightly modified a typical E300 to optimize its operation in low pressure environments. So what's included? Well, okay, the overall system is designed for flow rates of up to 300 MCF a day. It does have a stated 4-to-1 turn down. I will go on record saying that is conservative. With the inclusion of that makeup gas system, the VMS does ensure its ability to preserve reactor temperature when there's no gas coming from that battery. Let's say that it's the battery is undergoing service or tank bottom clean out. The VMS makes sure that it's ready to slam dunk on any oxygen that comes its way after that battery is put back into service. It's also fair to say 3-phase power is required, but it's also true to say that a single connection point does simplify that tie-in and keeps installation costs in check. Instead of having to run multiple power lines to multiple sources, there's just one point for electricians to tie in. Also, as we'll talk about more soon, everything is remotely monitored. Data training is provided. Can do that over multiple formats. We'll talk about that more later. So at this point, let's see the VMS in action as demonstrated by Ecovapor's own DJ Operations Superintendent, Charles Bidgood.
Yep. All right, my name is Charles Bidgood, and I'm the DJ Superintendent. Today we're going to be talking about the VMS unit for our Ecovapor system. In this application, we have a VRT that gets pulled off of another stream for another VRU. We process the tank vapors, so we pull it off the tanks, and it comes down this yellow pipe behind me here, and it's going to come into the system, and this will come into our blower system. It's a 25 horsepower blower system. Essentially, we will process that gas and shoot it down the inlet. We have some protective applications on the blower system, which include our Y strainer here. We have also a vacuum shutoff on the system, and then moving along here, we will send the gas down our inlet here, and it will go through our Ecovapor system. This is our E300. It will process the gas and create a catalytic reaction with the oxygen, stripping the oxygen away and passing out through our discharge. And on the other side of the system here, we have a watchdog that will monitor the oxygen, and if we have good gas, it'll go back down the discharge here, and it'll come into this bottom area where we have our sails and divert. If we see good gas, we will open up our sails valve and shoot the gas down to a booster VRU, which will go down the pipeline. If we see bad gas, we will have a quick action divert, which will send the gas up this yellow pipe here and down into the combustors. No gas is venting from the tanks. We are pulling everything from the tanks, and we are controlling that through our blower system with our 4 different speeds, depending on how many ounces are in the tanks at one time. So essentially behind me here, we have our combustors. They are currently off because we are selling the gas. So through our VFD controller, we are automatically controlling the tank pressure in the tanks, and that is allowing us to not vent anything from the tanks, and we are selling all of the gas down the sales line if the oxygen is good.
Cool. And as we'll look a little bit closer into in a minute, when we look at the actual data, just want to address that question that Charles posed of, is the gas good? That simply comes down to only one question, and that is whether or not power is available. Looking forward to showing more about that in the next couple of slides. But reviewing the performance of VMS that's been installed since August. To date, its performance has proven a few things. One, obviously, I think a good thing to lead off with is boosted production revenue. We're making more revenue because we're selling the richest gas on location instead of flaring it. So that makes sense. And at just 1/3 of its operational capacity, it's providing over $350,000 of realized revenue on an annual basis, which means that it has the potential to provide over $1 million of annual revenue if it's used at full capacity. Also on the emissions side, significant emissions reductions, really for the same reason as that boosted revenue stream. We're selling the gas, we're not flaring it. It makes sense. Yeah, and what we're seeing there is over 80 tons per year of avoided regulated pollutants like VOCs and NOx. And when we go to the unregulated pollutant side, we're preventing almost 5,000 metric tons of CO2 equivalent just by bolting on this equipment. In terms of using existing compression, if your site is currently equipped with a vapor recovery tower, a stabilizer, a surge tank, anything along those lines, that's great. The VMS is designed to piggyback on existing compression equipment, again, avoiding unnecessary LOE. It does provide 100% vapor capture. The controlled emissions are handled by leaving the flares dormant, and uncontrolled emissions are avoided by actively managing that tank pressure, ensuring that no venting occurs. Let's look at how else it's done in the field. So this process flow diagram describes how it's installed. In this instance, the data that we're about to go through, this VMS system is deployed on a large independent operator site in the northeast corner of the DJ Basin, currently capturing 75 to 100 MCF directly from the tank battery. We anticipate that volume is going to grow as the rest of the site is brought online. So just walking through what the VMS is from that process flow diagram, that central bubble it represents the system boundary. And included in that, you have your blower, you have your oxygen reactor, you have your control valves ensuring the gas goes where it needs to based on the quality. And again, all of this is maintained by a single PLC, ensuring compatibility between all equipment. It's seamless and operates in concert with one another. So again, this particular site started up in August, but we're going to zoom in on just 1 week of that runtime data to gain some insights. So this is the first of 2 slides where we're going to be looking at trends. There's going to be 3 trends on each slide. In this instance, we're looking at how tank pressure is actively controlled. That's the top line up there. Again, it's probably redundant at this point, but worth reiterating. No venting. We are actively controlling that pressure within a tight window, and it catches it if it goes on either side. The next one is the middle trend line is representing the blower speed, and the point there is that the blower adjusts its rate, its speed, its rate of vapor capture based on those continually changing site conditions. It knows how to adapt and respond no matter which direction things are heading. And then the last one is the trend line on the bottom represents that the discharge pressure is stable. Easy for Ecovapor's operators, the site operators to look at that data and see if something's changed, but also important to say that there's plenty of room to go. The maximum discharge pressure on this particular blower is 15 PSI, and we're keeping it right around 5. So plenty of room to run there. Again, this is actual operating data from the field. We would go into more months worth of data, but it just compresses the data too much, and wanted to showcase the resolution here. We're pulling each of these data points and putting it into Ecovapor servers with a 2-minute resolution. There are several ways for operators to obtain this data. We can integrate with your SCADA system. You tell us how. If you prefer Modbus RTU, we're going to ask you, okay, if you want to talk 232 or 485. If Ethernet's preferred, we got Modbus TCP. We have also configured to other protocols as desired by some of our clients. That happens simultaneously with Ecovapor's in-house monitoring, where we use virtual private networks that use cellular radios as their backbone. So Ecovapor works with 3 different carriers. We're working with Verizon, AT&T, and believe it or not, T-Mobile has saved our butts before when we got no service from either of the other 2. Originally the system was built to optimize Ecovapor's service personnel time and concentration, and we still use it that way. That's how we've earned the nickname of the Ghosts with one of our largest clients. That's because we using this tool, we can anticipate and see issues before they arise or become anything bigger. So that said, if the SCADA integration is something that is looked at as extra work, that's fine. Ecovapor can provide a login to our own web-based monitoring and data visualization platform, so no problem there. And in terms of performance, other than 2 power outages that occurred over this particular week, and actually I think it's just 2 over the entire lifespan of this installation, the overall data is honestly just as boring and in balance as what we see here. Let's move on to the next slide and look at the other data trends. So again, actual operating data from the field over the same week. This time we're looking at oxygen performance at the outlet, reactor temperature, and heater output. Takeaways there, I'd say, is that the O2 performance is directly tied to reactor temperature. If the reactor is hot, oxygen gets nuked. If it's not, then that catalyst isn't able to do much. That said, that reactor temperature is 100% self-managed by the VMS's controller. Again, the only question of whether the gas is going to be in spec when it's sold is whether power is available for the equipment to operate and do its job. So from the top 2 trends, I think we can take the conclusion that that oxygen is actively removed. Zero-2 technology has been refined over the years and absolutely nukes any oxygen that dare enter the inlet nozzle. And it's also no mistake that those reactor temperatures are tightly maintained. The only excursion from that set point was during power loss. That said, from the bottom trend on heater output, you do see that heater output bouncing around, and that's because the site bounces around. This is what we're talking about between passive management and active management. The site conditions change, from site to site, but also day to day, and actually second by second. Not only is flash gas generation rates varying, but also sort of gas compositions. From light to rich to super rich. It's not uncommon for us to see up to 3,500 BTU gas in these tank batteries in their vapor space. But also O2 concentrations vary based on site operation as well. And okay, we're talking about O2 concentrations, but if needed, the VMS can also be configured for sour applications as well. So I hope that that answers the questions of how it performs in the field. I'll pass it back over to Jason.
All right, thank you, Hans. Appreciate that. So as you can all hear, we're pretty excited about this product and about the applications it brings. We really do believe that this is an excellent bolt-on product that can really address some of that gas that can be left behind, some of that flash that can be left behind by your existing VRT and VRUs, or even a stabilizer that might be out there. So we love active pressure management. Venting and flaring are, of course, huge sources of emissions and huge sources of wasted product. And so, as you just saw with some of the monitoring we are doing as well, we can actively demonstrate that we are maintaining within the right pressure window to ensure that we are minimizing the likelihood of those venting operations. So overall, we think that this is a great way to profitably enable you to reduce your emissions while selling more gas, and we think it's easy to install and deploy in your operations. So, and one thing that we do at Ecovapor is we typically don't want to release a product until we've seen some field data, until we've seen results in the field that we know that we can stand behind. And as we've kind of shown here, we're proud that we do have this in the field. It is operating, and the customer is pleased with the results, and we're also pleased to report that number 2 will be installed tomorrow, or actually is already installed, will be commissioned and turned on tomorrow. So, with that, we'd like to thank you all for your time, your attention, and of course, now we'd like to open up for any questions that anyone may have for our panelists here. And thank you again for attending. Appreciate it.
Yeah, we've got a few questions, Jason and Hans and James, from the participants. One of these, Hans, what would cause the gas quality to be off spec? The video talks about diverting the gas. What are the causes of that?
Great question, Jeff. It can really, I guess the usual suspects are H2S and oxygen. H2S is something that oil fields used to dealing with. Typically, it's found in reservoirs, but we also have seen a number of instances where operators have been caught off guard where they have a sweet formation, but somehow they're getting sour gas on the outside, or on the sales side. That's typically because of biologic, right? I guess it's the origin of that H2S is biologic in nature. It can be bugs that are living in the bottom of the separator. Water tanks are also a usual suspect there. So if your gas gathering doesn't allow for sour takeaway, typically those cutoffs can be around 4 parts per million. This webinar is not about Ecovapor's Sulfur Sentinel product line, but that's how we address those issues. The other, and this is certainly more prevalent, is contamination by oxygen. There's a number of ways that O2 can get into the tanks. I think we know about most of them, but probably not all of them. There's what you might expect when water transfer pumps come on, when hatches are open for gauging, when during crude sales events, when oil is pulled from the tanks, that volume can be made up through inbreathing, but also, and I honestly talk about this for a long time, but I'll try to hit the highlight that Oxygen tries to go where it's not, and it's not unique to oxygen. That's part of any gas. They're seeking equilibrium. I like to say that air is not Caesar salad dressing. It mixes up. Like I said, it's seeking equilibrium. It goes to where it's not. And when there's an area or a space where oxygen or again any other gas is not, it looks at it like a vacuum. So a misnomer has been to essentially treat an atmospheric or a partial pressure problem with a gauge pressure solution, and that's what we see with gas blankets. Quick math is that you got about 3 psi of partial pressure of oxygen in the air trying to go where it's not. So by raising gauge pressure a few ounces, it really just comes down to the balance between diffusion rates, where essentially oxygen can swim upstream, versus the actual velocity that gas exits the keyword venting when it vents from the tanks. Can that oxygen swim upstream fast enough? And what we typically see is yes, it can. So what it really comes down to is how close the midstream group is looking at it. In some instances, the midstream group is a little bit more lenient, and that does provide operators probably more options. But in areas where there is scrutiny on the quality of gas that's being sold, it does seem that things are moving in one direction, certainly in the lower 48 at least, to monitor that. That's where that active control of those contaminants is key, because when the pipeline shuts you in, what we've seen is that their patience and understanding decreases as that happens more and more often. Does that answer the question?
Yes, thank you. We've got a couple of questions about the blower. One is the blower a screw type compressor?
No, it is not. And again, that is an attempt to lower that pain in the butt factor. I could, screw compression is another thing I could talk about for a long time, about how awesome it is, and how just the concept of using that engineered lube oil allows for more stages of compression, or more ratios of compression per stage is what I'm trying to say. Screw compression is fantastic, but it also is more complicated than what Ecovapor set out to provide to the market here. It does require that active lubrication. You need to consider dew points for the gas, and ensuring that you're maintaining temperatures above those dew points so that you don't foul that lubrication. What Ecovapor is using is, again, I use the term Goldilocks probably too often, but what we're trying to do is achieve required pressure, discharge pressures, and then some. But again, minimizing those maintenance requirements, which ultimately translate to higher LOE.
Okay. Another question here. The question has to do with routing the gas back to the VRT compressor suction, and does that create problems with tower performance?
Great question. It shouldn't, and really what it just comes down to is ensuring that set points are working in concert and not against each other. So what I mean by that is, by allowing that discharge pressure on the blower that Ecovapor spec'd here to get up to 15 psi, that means that the VMS can deliver gas up to 15 psi. And although there might be a couple operators that choose to operate their vapor recovery towers at higher pressures than that, the vast majority typically stick between 3 and 4, maybe 5, sometimes 2 psi, but a tighter window right there. And inherently, Ecovapor's blower will essentially rise to the occasion. So whatever the set point is for that compressor that's pulling gas directly from the vapor recovery tower, that's how vapor recovery tower pressures are typically maintained. There might be a back pressure regulator in there somewhere as well, depending on the facility that we're talking about. But ultimately, it doesn't really matter. The 0.2 adapts to those conditions. It stays within Ecovapor's theme of trying to provide equipment that meets that application, that well site where it's at, rather than asking that operator to adjust their operations to an additional piece of equipment that's showing up on site.
Okay. We've got a question here. Does Ecovapor have any downstream applications?
Downstream applications. Gee, that's a good question. I think it.
Yeah, I mean, we've talked to a number of downstream companies in the past. We haven't installed anything at a refinery at this point, but those discussions have been underway. We've also, I would guess RNG biogas would be considered some form of midstream, really not downstream, but I guess what I wanted to make the point is we are pursuing opportunities outside of our traditional upstream oil and gas sector as they present themselves, and we can provide value to the operator. Jason and Hans?
Yeah, and the only thing I'd add on to that, Jeff, is we continue to refine the product line. We continue to invest in new developments, including larger units that, of course, would fit different types of applications than our typical E300 which may be more designed for a tank battery application in an upstream setting. We do have larger, E1200 and even larger coming. So as we continue to learn more and more about some of these challenges and some of these market opportunities, we of course continue to develop new applications. So, would love to connect with you if you have any further questions around what you're looking for on the downstream application. And who knows, we may have something that suits your needs, and if not, maybe we can talk about what is needed.
Okay, and then Hans, I'm going to have to read this one verbatim to you. So the question from the operator is: a VRT required for the Tank Commander? A challenge in our region is the waxiness of the oil below 140. And we know wax and VRTs are issues. We flash everything in the tank. Sometimes we see 1.4 million a day of flash at peak. Could you run multiple Tank Commanders to handle high rates?
So a couple questions in there. I'm going to address them in backwards order. So Ecovapor can match whatever capacity your facility has, and we do that intentionally by designing equipment, both Tank Commanders as well as the 02 product line itself, to be stackable in parallel. Not only do we offer multiple capacities of individual skids, 100, 300, 1.2 million. As Jason mentioned, we're branching out on either side of that, but those can be stacked in parallel. I couldn't even tell you how many sites we have two 02s in parallel, or even three. We've had sites with 4, we've had sites with 5, we've had sites with 6 in parallel. So the 1.4 million, not a challenge. We currently handle facilities with higher flash rates than that today. That said, if no, whether it's a VRT or like I said, stabilizer, surge tank, anything in that class of equipment that operates at, I'd say, 5 PSI or below, the tank, if there's not compression already on site, then compression would be required. So in that instance, there's the potential to use the Tank Commander to harvest and process that gas from the battery itself, and then feed that into a compressor, or I'd say at least to date, the more we have many more units deployed in a configuration where a vapor recovery unit, a compressor like a screw compressor we mentioned earlier, could harvest all that gas directly from the tank battery, maintain that tank pressure set point, and then the 02 would process the gas from the discharge there. So lots of options. I promise it's something that we've seen already, and if we wanted to take a closer look at that individual application with that operator, we'd be more than happy to propose what we think would be the right solution.
Okay, thank you, Hans. I've got one more question here. The question is, where is the gas routed if there's no VRT?
Probably similar answer to, if I understand the question correctly, then it's probably a similar answer to the last question, in that if there's not a vapor recovery tower, honestly, your facility design is even more simplified. Capture the gas at the tanks, that's where all of it's going to be. And there's plenty of compression providers that are used to tank vapor applications that we work with today. In that instance, you'd only need the reactor, the 0-2 side of the Tank Commander equation. And again, the theme here is 100% full capture, regardless of what that application looks like today. We can handle it.
Okay, great. James, that's all we got on questions.
All right. Thank you so much. Big thanks to our panel today. Appreciate you guys coming on. Jason, Hans, and Jeff. That was great presentation. Just a couple things before we wrap up. We mentioned and showed a couple of slides from Ecovapor's previous webinar, The Road to Net Zero Goes Through Your Tanks. If you're interested in more detail, it's a great event where Bridger Photonics and Ecovapor present a variety of case studies. Find it on the Ecovapor website under News and Resources. Just a reminder that today's slides are available in the PDF download at the bottom of your GoToWebinar control panel. And there are also more resources available on the Tank Commander webpage on the Ecovapor website under Solutions. So thanks again for your time and attention. Please contact our panel with any questions. Their contact information is also in the handouts. And we hope you have a great rest of your day.
Thanks, guys.
Thank you.
Thank you.